Keerthi thinks that substitution reaction occurs in saturated hydrocarbons. On the contrary, Krishi thinks it occurs in unsaturated hydrocarbons. Justify with valid reasoning whose thinking is correct. Let's first see the key characteristics of saturated and unsaturated hydrocarbons. Saturated hydrocarbons have single bonds, where each bond is attached to an atom. They are highly stable, so it's not possible to add another atom, and they react with halogens via halogenation, which substitutes a hydrogen atom with a halogen atom. On the other hand, unsaturated hydrocarbons have double or triple bonds, where two or three bonds are attached to the same atom. They have unstable pi bonds that can be broken easily. So they undergo addition reactions, where hydrogen is added to convert an unsaturated hydrocarbon to a saturated hydrocarbon. Thus, Keerthi's thinking is correct as substitution reaction occurs in saturated hydrocarbons. Hydrogen atoms are replaced with heteroatoms in saturated hydrocarbons. Whereas in unsaturated hydrocarbons, an addition reaction occurs. Simple molecules are added across double or triple bonds. Second part of the question is, methane and propane and their isomers are used as fuels. Comment. Also draw the electron dot structure of the immediate lower homologue of propane. Give any two characteristics of homologues of a given homologous series. Now, both methane and propane produce a substantial amount of heat when burned, making them valuable for generating energy. Methane is the primary component of natural gas, while propane is readily extracted from petroleum, making them widely accessible. When completely combusted, they primarily produce carbon dioxide and water, considered relatively cleaner compared to some other fuels. Even though isomers have different structural arrangements, they generally share similar combustion properties, making them useful as fuels. Thus, we can conclude that methane and propane, along with their isomers, are used as fuels because they readily undergo combustion reactions, releasing a significant amount of energy when burned, making them efficient fuel sources with readily available hydrogen atoms to react with oxygen. Next is, draw the electron dot structure of the immediate lower homologue of propane. Now, the lower homologue of propane is ethane. Its electron dot structure is this, where two carbon atoms are singly bonded to each other, with each carbon atom further bonded to three hydrogen atoms, resulting in a structure where each carbon is surrounded by 8 valence electrons, that is a complete octet, and each hydrogen has 2 electrons, a duet, fulfilling the octet rule. And finally, two key characteristics of homologues within homologous series are, let's first get to know what a homologous series is. So, it is a series of carbon compounds that have different number of carbon atoms but contain the same functional group. For example, methane, ethane, propane, butane, etc. They are all parts of the alkane homologous series. Two key characteristics of homologues within a homologous series are, all members of a homologous series have the same functional group, which is a specific group of atoms responsible for the characteristic chemical reactions of that series. When moving from one homologue to the next in a series, the only difference is the addition of one more CH2 group to the carbon chain, leading to a predictable increase in molecular weight and often a gradual change in physical properties like boiling point. Interesting, right? Now, the last part of the question is, a mixture of oxygen and ethyne is burnt for welding. Can you predict why a mixture of ethyne and air is not used? Well, a mixture of ethyne, that is acetylene, and air is not used for welding because burning ethyne in air produces a sooty flame due, due to incomplete combustion, which doesn't reach the high temperature needed to melt metals for welding. Instead, pure oxygen is used to create a clean, extremely hot flame with ethyne for welding purposes. The image shows a banana plant which is growing with the help of suckers. These suckers are small plant stem outgrowths which can be separated from the main plant and planted separately, and they will grow into a new plant subsequently. Give the name and type of reproduction that is shown in the image above. Since new plants develop from vegetative parts of the parent plant and not from seeds, it is vegetative propagation or asexual reproduction. List two advantages the farmer will have on using the type of reproduction here. Advantages of asexual reproduction for farmer are more crops in same time interval, genetically identical plant, flower fruit faster, and there is no dependency on pollinators. Next is the above plant produces male flowers. Explain how this plant will be involved in the process of pollination. Well, in this case, the pollen from anther will be transferred to the stigma of another banana plant using the agents like wind, water, or insects, etc. This process is called cross pollination. The last part is, why is the offspring of this banana plant not absolutely identical to its parent plant? Well, that can be due to some minor variation during the process of copying of the DNA. Here is a developing fetus in the mother's womb. The developing fetus is connected to the placenta by means of umbilical cord. The umbilical vein and artery run inside the umbilical cord. Name two substances that move through the blood vessels. These substances are nutrients, glucose, oxygen, and waste. If the placenta has less villi, how will it affect the baby's growth? Villi are finger-like projections in the placenta that increase the surface area for the exchange of oxygen and nutrients between the mother and fetus. When there are fewer villi, the surface area for exchange is reduced. This can lead to fetus receiving less oxygen and nutrients, which can cause restricted growth and developmental issues. Placental insufficiency can also lead to premature birth and other pregnancy complications. So, this condition is called placental insufficiency. Name the region where the embryo develops inside the female body. The uterus, also known as womb, is the region of the female body where an embryo develops. It's a pear-shaped organ in the pelvis. Explain how this region is adapted for nourishing the baby. Here we go. The adaptations are thick muscular walls. The myometrium, which is the muscular layer, provides strength for expansion during pregnancy and contractions during labor. Endometrium, or the inner lining. It thickens each menstrual cycle to prepare for implantation. It has a rich blood supply to deliver oxygen and nutrients to the embryo. Placenta formation. The placenta develops within the uterus, connecting to the baby via the umbilical cord. It facilitates the exchange of nutrients, oxygen, and waste between mother and baby. Amniotic fluid. The uterus holds amniotic fluid which cushions the baby, maintains the temperature, and allows movement for proper development. Hormonal support. Hormones like progesterone and estrogen maintain the uterus lining. suppress immune responses to prevent rejection of the baby, and prepare the body for labor. And last but not the least, definitely, increased blood supply. The uterus receives a significantly increased blood flow during pregnancy to support fetal growth. All these adaptations ensure that the baby receives necessary nutrients, oxygen, and protection throughout pregnancy. Some of the fetal cells fall off into the amniotic fluid and can be collected by careful procedure. The cells were screened and found to contain XY chromosome. What is the sex of the fetus? XY chromosome signifies a male child. How is this prenatal sex determination misused? Some people engage in aborting the female child, leading to female feticide. This circuit is a part of an electrical device, and we need to calculate first the potential difference across R2. We can see that 4 ohm resistor is in parallel with resistor R2. Therefore, potential difference across both would be the same, which is I times R, so 1.5 times 4, 6 volts. Next is find the value of resistance R2. Now total current through 4 ohm resistor and R2 is 2 amperes, we are given that. And we are also given that current through 4 ohm resistor is 1.5 amperes. Thus, current through R2 would be 0.5 amperes. Now using Ohm's law for R2, we get 6 equal to 0.5 times R2. Hence, R2 is 12 ohms. Now the last part of the question is find the value of resistance R1. Potential difference across R1 would be total potential difference minus potential difference across R2 minus potential difference across 2 ohm resistor, right? So, first potential difference across 2 ohm resistor would be 2 times 2, that is 4 volts. Potential difference across R2 is 6 volts, we calculated it before. So potential difference across R1 would be 2 volts. Now we know that current through R1 is 2 amperes. Using Ohm's law, we get R1 equal to 1 ohms. As shown in the figure here, A and B are 2 lamps. Lamp A is rated at 12 volts and 24 watts. Lamp B is rated at 6 volts. When lamp B operates at its rated voltage, the current in it is 3 amperes. The values of R1 and R2 are chosen so that both lamps operate at their rated voltages. Based on this information, calculate the current in lamp A. P is V times I. So I is P divided by V. So 24 divided by 12, we get current as 2 amperes. Current in lamp A is 2 amperes. Next is, and give reasons for the reading of the voltmeter. See that voltmeter reading is 12 volts. Lamp A and B are in parallel, hence potential difference across the arm containing A would be equal to potential difference across arm containing B. So it would be 12 volts. Calculate the resistance of R2. Potential difference across R2 plus potential difference across B is 12 volts. Potential difference across B is 6 volts, we are given that. Hence, potential difference across R2 would be 6 volts as well. Now current through R2 would be current through B, which is 3 amperes. R is V upon I, so R2 would be 2 ohms. And lastly, find the value of the resistance R1. Current through R1 is equal to total current, that is 3 amperes plus 2 amperes, 5 amperes. Potential difference across R1 would be 3 volts. So R1 would be 0.6 ohms.